Hello everyone and welcome to another episode. So this is the next episode of the Conic section series, which is Ellipse. So today we're going to be talking about Ellipse. Okay. So today we're talking about Ellipse. So Ellipse looks like a squashed circle. So when you complex a circle from vertical directions, then you get something like this, like a circle that, however, we can see that the things which originally supposed to be the radius has been compressed and be shortened. So this is kind of like a weighted circle. So first we know that every conic sections will have a series of points that were used to construct them. For example, we can see that a parabola, you have this is a foci, which the distance, which these two distances are congruent. Or you have circle, where circle is pretty clear that we have circle. Then since circle is the locus, that all these points are equidistant, so the center is a foci. But how about an ellipse or hyperbola, which is more complicated, which we'll talk about in the next episode. But first, let's talk about hyperbola. How about ellipse? So what is the point that we use to construct this ellipse? Well, you cannot say the center, because when you say center, then since this line is not equal to this line, why don't we just say that this should be somewhere like the circle, like the radius of the circle? Actually, now the case is different. The foci is not the center. So the foci, there are actually two focus points, which foci, since this is the plural form of focus. So foci is going to be somewhere over here, which is between the end of the major axis and the center. And one thing to notice about it is that the length between the foci and the center is always going to be equal. Let's just call this P. So now, how is the ellipse constructed by these 2 points? How is this even related? So we have to know about a really important definition of ellipse, which, let's say we have a random point. Let's just call this x comma y, which we use it to derive the equation later. Then we can see that these two lengths, the sum of these two lengths, well, they're not necessarily be equal. Well, it's obviously not equal for some cases, but the sum is always going to be constant. So let this be d1. Let's just call this d1 and call this d2. Then we can see that the quantity of d1 plus d2, which is the sum of the distance from a point on the ellipse to the two focus points, are always going to be equal. So no matter we choose a point like let's say here, then d1 and d2, d1 is this and d2 is this, then they are always constant. So let me just erase this, since we don't have too much space to draw everything. So let me expand this. Well, now what we know is that since we want them to be the equal, then we want to find P. So what is P? So we want to find the value of P. So first we're going to pick the point over here, which is the end of the major axis. So let this, well, so since the center is going to be h comma k, then we can see that if we let the major axis be a, or the major radius be a and the minor radius be b, then we'll find what is the question mark distance, which is p. So now what we'll do is, we can see that when we have here, then you have, well, let this point be h, then we're going to have 2a minus h, which is this distance, plus h, which these will cancel. So we can see that the distance, or the sum of the distance must be equal to 2a, which a is the major radius, so a is here, right? So you see that the question mark, which I'll erase it out now. So what is this equal to? So this is just equal to, well, so the sum of the distance must be equal to 2a, right? So now we want to find p, which will just pick a distance here, and we're going to draw these two line segments. So we can see that since these two are equidistant, and obviously there are right angles, and these are equal, then these two must be equal. So now we can just set up an equation. So we have 2a is equal to what? It's equal to the square root of p squared plus b squared, and this times 2. Since this line segment by Pythagoras theorem, the length is equal to the square root of p squared plus b squared. So we can cancel these out, then we get a is equal to the square root of p squared plus b squared. Well, this actually seems pretty familiar. Well, why? It's because we can say that we have a triangle, a right triangle with this is p, this is b, then this is equal to the square root of p squared plus b squared. Right? By Pythagorean theorem. So now we can get that p is just equal to what? Square root of a squared minus b squared. Right? Which a, as I mentioned, is just the length. So let me just label it. New line, new color, then we have square root of a squared minus b squared. So let me just erase everything. So now what do we have? So since by definition the sum of the distance must be equal, then we can set up the equation. So let the point be x comma y. Then we can see that the foci. So this is, well, to make the calculation more easy, then we're going to let square root of a squared minus b squared equal to p. Since this will make the calculation more easy, easier. Sorry for that. So now we can say that x minus p squared plus, well, this is what? So this is actually h minus p comma k, and this is h comma plus p comma k. Let me just erase this out. So we'll have, well, x minus plus p squared plus y minus k squared, since this quantity is always going to be constant, plus the square root of x minus h minus p squared plus y minus k squared. Also, this entire quantity is just equal to 2a. Well, people will think that this will be way more complicated to calculate, but so we want to eliminate the radicals, which will just bring one radical to the side. So we can see that this one's smaller than this one, or, well, they're both like the same. So, well, this doesn't really matter. So now we're going to have, so the square root of x minus h p squared plus y minus k squared equal to 2a minus square root of x minus h plus p squared plus what? Plus y minus k squared, right? So now we'll square both sides to eliminate this entire radical. So what we'll do is we'll have So we have x minus h minus p square, this entire thing square, plus y minus k square. Or this will be squared, this then will get 4a square minus or x minus h plus p. We actually plus this plus y minus k square. Then we minus 4a times the square root of this thing. Of the thing which I'm not going to write. So notice that these two cancels out. Then we have x squared minus plus h minus p square plus, well, there's some more plus, these two both cancels out. So this is just equal to, no, actually we have plus 2x, no, minus 2x times h minus p, minus 2x times h minus p. Well, this entire thing is just equal to 4a squared plus x minus h plus p minus 4a times the square root of this entire thing, which is just equal to this, right? So now we can see that things further cancels out, which, well, want to make stuff cancel out, right? So now we can rewrite this as x squared plus h plus p squared, and then minus this. So we can see that this is just equal to 4a squared plus x squared plus h plus p squared minus 2x times h plus p minus 4a times the square root of this entire thing. So we can see that these two cancels out, and these two you'll just leave this as negative 2hp. Since h squared plus p squared was cancelled out, so we get this as 2hp, and all these cancels out, so we have this is equal to 2xp, and this is minus 2xp plus 4a squared minus 4a times the square root of something that's kind of annoying. I'm going to write that out. So we add both sides, and now we have x for 4xp minus 4hp is equal to 4a squared minus 4a times the square root of this. Well, now what's going to happen is we divide both sides by 4 in case you didn't realize. These 4 cancels out. So we can actually factor this. So we have x minus h times p with a squared minus 4 minus a times the square root. I wish I can just copy paste it. So let me drag it down furthermore. Well, now I have to write it because if I don't write it, then I cannot see it. Here we have x squared minus h minus x minus h times p just equal to a times the square root of x minus h plus p squared plus y minus k squared. Well, now it seems pretty tedious, but we're going to try to expand this, even though it seems pretty tedious. So get that. Well, this is just equal to a to the 4th minus well, x minus h squared p squared minus 2a squared p times x minus h. Well, this is just equal to a squared times x minus h plus p squared plus y minus k. So just expand this out, and well, actually this might be somehow a good time to substitute back, but we'll just wait a little bit. So we have a to the fourth plus x minus h squared p squared minus 2a p times x minus h. Well, we'll simplify this a little bit. So we have a squared times the entire thing times x squared plus h plus p squared minus 2x times h plus p plus y minus k squared. So now, furthermore, we have a to the fourth plus x minus h squared times. So actually, we can just now take this out. So we have minus 2a squared p. Well, since we don't have that square, so we don't have to take it out right now. So this is equal to a squared x squared plus a squared times plus a squared p squared times a squared times a squared minus b squared minus 2x times h plus p 2x x plus p. Actually, I forgot to multiply by x by a square. So 2a square x square 2a square x times h plus p, and then plus a square times y minus k square. So now we can see that these two terms cancels out, right? Even though you didn't recognize it. And now we have we kind of want these two cancel out, but it seems like it's not working too good. I'll just simplify it a bit more. So a squared times x minus h squared minus b squared times x minus h squared minus 2a squared p times x minus h. Well, actually, this you can probably use the distributive formula, but we'll see how it goes. So we have a squared x squared plus a squared h squared minus a squared b squared, then minus 2a squared. Well, we have 2a squared p, but we want 2a squared x, right? 2a squared xh plus, well, minus 2a squared xp then plus a squared times y minus k squared. So is there anything that we can probably cancel out? Oh, so we can see that these two looks kind of similar, so we have 2x squared plus 2a squared ph. Well, now I think we should just put it back since we still have n, right? So we have now, we can replace this with so now we will further just go in and just try to bash it out. So is this even going to work? Wait, can I just combine this like actually? So we have x minus h squared. It is kind of like hard to write. Since I just type it, I really fast on computer, but kind of have b squared. Actually, no. I think since it doesn't really like match our final equation, so actually we're gonna turn this as so this should be 2a squared square root of a squared minus b squared times x plus h, and if these two can cancel out, I know actually it's x minus h. So square p, okay, is equal to a squared minus h dx. I don't think I made any mistake though. So I have a squared x squared plus a squared h squared plus a square minus b squared. Plus p plus a squared times minus a squared. Wait, by the way, I just realized something. So by algebra manipulation, then we can see that this entire thing cancels out with these, and these, right? So now we have and now can we see if we can cancel out any other stuff? On these two just cancels out, right? Yeah. What the heck is this thing even doing over here? So I think there must be something that cancels out with it. Oh wait. Well, I think I just forgot that this plus 2 HP here, so this will also cancel. So now we have so now we just have a squared b squared is equal to a squared times y minus k squared is equal to b squared times x minus h squared plus a squared y minus k squared. When we divide entire thing by a squared b squared, then now you get to the conclusion that you have 1. So you have x minus h squared over a squared plus y minus k squared over b squared. Well, this thing is just equal to 1, which this is our equation for the ellipse. So now conclusion, we have to draw a conclusion about, wait, where did everything go? So we have to draw a conclusion about the ellipse. So we can see that, so each point that satisfies this equation that x minus h squared over a squared plus y minus k squared over b squared is equal to 1 satisfies each point, then those points will be on the ellipse with a equal to the major radius and b equal to minor radius. Well, actually, if you have an ellipse with a vertical ellipse, so all the cases when you have something like this, right? Then the b will be in the front and a will be in the back, and we can use the same process to induct what is the equation. Thank you for watching. Have a great day and see you next time.